Have you ever wondered how we know a function is continuous? Let's say that we have a point A and a point B on a continuous function. How can we prove that this function is continuous through and through? Luckily, we have the intermediate value theorem. This theorem essentially states that if the function f is continuous for all x in the closed interval a, b, and y is a number between f of a and f of b, then there is a number x equals c in AB for which f of c equals y. This essentially means that if you have a point fa and a point fb on a function, and know a number y is between them, you know there is an fc and that is y. Let's take a look at some of the history of the IVT. The IVT was first discovered in 1817 by Bernard Bolzano, a Catholic priest. It had been partially discovered by a Flemish mathematician by the name of Simon Stevin in the 1500s, but it wasn't until Bolzano that it was officially discovered. Bolzano was of Catholic religion at the philosophical faculty of the University of Prague, an outstanding mathematician and one of the greatest logicians to live in his time. An accomplished man, he ran on philosophy and the military. Most importantly, he discovered that the IVT value theorem. However, it wasn't until 1821 that this theory was actually proven. Augustin Louis Cauchy, a man who had fled the French Revolution and then worked as an engineer, proved the IVT and earned himself respect among mathematical communities. Today, they are seen as some of the greatest mathematicians of their time. Let's revisit what the IVT actually says. If the function f is continuous for all x in the closed interval a, b, and y is a number between f of a and f of b, then there is a number x equals c in AB for which f of c equals y. Remember, this basically means if you have a point fa and a point fb on a function and know a number y is between them, you know there is an fc that is y. But what does this really mean? Let's take a look at a practice problem. The problem here is that fx equals x cubed minus 4x squared plus 2x plus 7 in the interval 1, 3 for which f of c equals 5. Let's graph it on our paper to get an idea. In this problem, 1 is a and 3 is b. To find if there is a number x equals c between these 2 points, or in other words, if it is continuous throughout, we can use the intersection feature on our grapher. First, plot the function in the y1. Remember, at y2, plug in only 5 to get a straight line at y equals 5. Adjust your window and plot. We can see here that FA or F1 is 6 and FB or F3 is 4. The number 5 is between 4 and 6, so we know the point x equals c where FC is 5 exists. Look, at F 1.311 equals 5. Wow, the IVT really works. And you might be thinking, how does this apply to real life? Isn't higher math just theoretical unless you want to be a teacher or an engineer? Of course not. The IVT can be used to find our height, for example. If Ben knows he used to be 3 feet tall and is now 5 feet tall and wants to know if he was ever 4 feet tall, he can use the IVT to know that since 4 is between 3 and 5, he must have at some point been exactly 4 feet tall since his height is a continuous function. Another example would be with distance. Say a kid is playing with a ball and it rolls down a hill. Rolling down the hill, at 1 second it was 30 feet from the top and the next second was 35 feet from the top. There must be a time y in between this time interval where the ball was 33 feet from the top, since 33 is between 30 and 35. Complex problems like these can be solved using only the IVT. As you can see, the IVT is something that looks confusing and daunting when you see it, just like many things in calculus, but in reality is something that any student can learn and understand. It is totally doable. Remember, the IVT states If the function f is continuous for all x in the closed interval ab, and y is a number between f of a and f of b, then there is a number x equals c in ab for which f of c equals y. Never forget, this means if you have a point fa and a point fb on a function and know a number y is between them, you know there is an fc that is y. Thanks for watching.